Okay, so this will be a talk on PL SQL. It's a talk I've given previously at Oracle Open World, but sort of the agenda is starting with why use PL SQL in the first place, then taking a look at a couple of things about PL SQL you can keep in mind, write as little as you can, use packages, using static SQL, bulk processing, implicit versus explicit cursors, then beware of some features, some things I would encourage you to avoid in PL SQL, and then close up with some things to definitely do when you're developing in PL SQL. Now, as far as the why PL SQL, it is a real language. I frequently meet developers who believe that because it's a stored procedure language, it's like a little scripting language. It's not a real programming language. If you take a look at PL SQL and you take a look at the language, I've programmed in a lot of different languages, C, C++, Java, Ada, PL1, COBOL, many different programming languages, and PL SQL is right up there with the rest of them as far as capabilities, as far as being a 3GL programming language. And remember, it is the API to the database. In many cases, you're already coding PL SQL whether you want to or not, whether you be calling it from Java or C# or whatever, but a lot of your life is going to be invoking and using PL SQL in the first place. If your goal is to procedurally process data, after you make sure a single SQL statement can not do it, then PL SQL is simply the most productive language on the planet to do that. If I wanted to loop over all the rows in the table and do some process to them, the PL SQL to do this, and this is optimal PL SQL, as we'll see in the bulk binding section, this does things like array fetching for me and everything. This is optimal PL SQL in order to process all the records in the table, do some process against them. And if you notice things like the data types, I don't have to declare variables. I didn't even declare any variables in this particular example. I didn't have to, because all the type, %row type, and in this case using an implicit cursor, I didn't really have to do anything. I'm protected to use select star. It's a bad practice. If this select star was in a 3GL program outside the database like Java or C#, it would be really unsafe. What if somebody came and added a column to the table and you were programming outside the database and it used select star? In those environments, your program would probably break because it now has an extra column that you're not set up to deal with. In this environment, if I alter that table and add a column or remove a column, this code takes care of itself. If I modify the data type of the column, the code takes care of itself. So in many cases, PL SQL can be somewhat self-repairing. If you compare this to the Java, you might have to write to do the same thing procedurally in a Java application. It might look like this. You're going to have to declare the variables, and you're going to have to figure out what the right data type is. In this example, I actually have a bug in my code because I mistakenly used an int for the salary, but sal is a 7,2 or a 5,2 or something like that. So that's the inappropriate data type here. And then the question would be, if I did want to take that number 7,2 and put it into a Java variable, what's the right data type for that? Or if I was in C, what's the right data type to put a number 7,2 into? A C programmer might say a float, of course, or a double. But they would quickly find out that if they took that number 7,2 and they put it into a C float or a Java float or a C# float, and then they put it back in the database, they would end up with a completely different number. because the floating point numbers in C, Java, and such don't have the same precision capabilities as the Oracle number type does. And when you take it out, put it into a float, and put it back in, you invariably will have changed the data. So coming up with the right data types requires a lot of thought, especially if you want to preserve the data. Make sure that you don't damage it. And then you've got to prepare statements, and you got to make sure that you parse the statement. Well, here's a problem, because if I parse the statement, then I'm very tempted to immediately close the statement as fast as I can. That means if I call this subroutine 500 times, it'll actually parse the SQL statement 500 times. In PL SQL, there's optimizations. If I call this stored procedure 500 times, that SQL statement will be parsed once. PL SQL caches these statements open for me. Other languages don't have that necessarily built in. The programmer would have to take care of that. And so there's a lot of work here. The data type mapping, there's no tight coupling between the language Java, C#, Visual Basic, etc., and the database itself. They're two completely disconnected things. There's no code shortcuts, the statement caching that I was talking about, and you're not protected from database changes. If something changed in the database, you would have to come and revisit this code because the data type would have changed and the code wouldn't automatically reflect that, or maybe they added a column or took a column away and the code wouldn't automatically reflect that. It is the most advanced portable language I've ever seen. Sometimes when I say that, I get looks on people's faces like, portable? What are you kidding? It works in one database. Yeah, but it works in one database that's on virtually every platform you could ever consider running on. It is portable beyond belief. We go to large extremes to make sure that if we have a bug on one platform, we have the same bug on every single platform, right? In a Java virtual machine, they're all somewhat different. So even though Java is a portable language, you pick up the code from one platform and plop it down on another, odds are there's going to be something that's different as you move from virtual machine to virtual machine. You know, anything that can connect to the database can use and reuse PL SQL. A lot of developers talk about code reusability. The most reused components on the planet are your stored procedures. Whether you're in Oracle, SQL Server, or whatever database it is, as you change and evolve over time, your stored procedures stay in the database. You're using different programming languages, different programming frameworks. You know, the way we develop applications today in the year 2010, very different from the way we did it in 1995. But there's still stored procedures that were written in 1995 that are used today. It's portable, it's reusable. There are things like SOA and web services that can make languages like Java and others, you know, sort of portable in the same sense. If I set up a web service, in theory, anybody can invoke the web service from any other language. But that's a layer of complexity that goes beyond what most people need or want. If you can connect to the database, pretty much everything can, you can use and reuse PL SQL from anything. Many mistakes made in other languages using the database are avoided. Bind variables. This is something, if you've read any of my stuff, you know I write about bind variables a lot and the proper use of them. If you're using PL SQL and you avoid dynamic SQL, you just use static SQL inside of PL SQL itself, it is impossible to not use bind variables correctly. That's a really powerful statement. Somebody's running into scalability issues, they've got poor database performance, 99 times out of 100, I swear, it's because of improper use of bind variables, and they're killing the system with literal SQL. It happens over and over and over again. Start using PL SQL, it's impossible to get bind variables wrong. Parse once, execute many. PL SQL always does statement caching. In other environments, you have to go out of your way to make that happen. In PL SQL, when you say close cursor, PL SQL says, no, not really. I'll pretend that it's closed, you'll pretend that it's closed, but we're going to keep it open. Because I know you're going to call this stored procedure again, and you're going to execute this SQL again, and we'll just re-execute the SQL instead of having to parse it to compile it. Schema changes are safer. I can modify data types. And as long as I code it my PL SQL intelligently, use the native capabilities, %row type, %type, I can do things like modify a column and make it wider, and I know that change will trickle throughout all of my code. Do that in a Java program, do that in a C application, and you've got to now go through the code and manually make changes. However, I don't want to oversell something. With PL SQL, you can write really good code, you can write average code, and you can write some of the worst code on the planet. Right? I've seen that as well. Just because it has all those good attributes does not mean it will make you a better programmer than you are. You still need good programmers, don't get me wrong. You can make mistakes by not understanding the language, by not understanding SQL. I was giving a talk not too long ago, and there was a panel session after the talk where they could ask questions of the speakers for that day. And one of the questions I got was, what do I think is the most underutilized feature of the database? And the person asking it was probably expecting to hear something like, I think advanced queues, or I think feature X, right? But a specific feature. And I thought for a second, and I said, I think the most underused feature of the database is SQL, period. And they said, what do you mean? Everybody uses SQL. I said, yeah, but everybody uses this much SQL, and there's this much SQL out there. Right? So by not understanding what you can and cannot do inside of these languages, you can defeat their goodness. So on the topic of writing as little as you can, write as much code as you have to, but as little as you can get away with. Think in sets. Really use SQL. Look at your procedural processes and ask yourself, is there a way I could implement this in a SQL statement rather than writing procedural code? You know, for X and select star from a table. Let me loop over it, insert into a local table. This should be a single SQL statement. This should simply be insert into a table, select star from another table. But many developers will do this because they're procedural programmers. They think this way. They're not thinking in set-oriented capabilities. Or they'll come up with an excuse like, well, I need to make sure that if one of those records fails in the insert, I skip it, I log it or something like that, and I process all the records that I can. Well, keep up with database features. As of 10G, you can do that. You know, if the goal was to load as many records as possible and log failed records into another table, I could write more and more code to do that. I could have an exception block and insert into another table and so on. Or I could just use the log errors clause. That says insert into that table everything you can, log the errors into this other table, reject limit unlimited. It will go ahead and put as many as it can into the table, the rest into a log table. Just like using the bad file in SQL Loader would. SQL Loader can load all the good records and log the bad ones off into another file. Keep up with SQL, figure out what it can and cannot do, and do as much as you can inside of SQL without writing code. Less code equals less bugs. Here's another coding technique I see frequently. I want to take it easy on the database. I heard that databases doing joins is bad. I hear that sorting data in a database is bad. So I want to take it easy on it. And they'll do something like this. For A and select star from a big table. Then what I'll do is I'll take the key from that and I'll hit table T2 with a really easy small query that just does an index read and gets the record from T2. And for every record I get from that, I'll do another small index read into T3. Because you know, if I put all three tables into a single query and I join them together, Oracle would use that dreaded full scan thing. You know, and full scans are bad, they're evil. They're bad, they're evil if you're getting a small amount of data. If you're getting all the rows from T1, 2, and 3, we want to join together. This is going to take hours or days to complete, yet I see it happen over and over and over again. Don't try to outthink the database. Just pack whatever you can into a single SQL statement. More code equals more bugs. Less code equals less bugs. So here was a code snippet that I found on a nice website. It's called Oracle WTF. That stands for worse than failure, of course, not what you guys are thinking. But here was a piece of code somebody had developed. So a nice PL SQL code, get ID, send some inputs, get some outputs. And what they do in this code is they call yet another procedural process, lookup ID. That must be running a SQL statement with a select into or something, returning the number 0 if it's not found. Okay. So it's using return codes. I don't really like that, but whatever. We get this ID. Then we go into this loop. While new ID is equal to 0 and Vmax tries is greater than 0. Vmax tries starts at 127. So this will basically loop while this new ID is 0, and they'll try to do this insert into a table. And when it fails, when anything happens, we'll ignore it, right? And then we'll decrement that counter. Now, if it succeeded, the new ID would not be 0 anymore. It would have sequence.curval, and we'd break out of the loop. Otherwise, if it failed, we'd try it again, and again, and again, 127 times. Have you ever done an insert statement where it failed, and then you just re-execute it right away, and it worked? Where's the logic in here, right? This should have been a very small subroutine with simply 2 SQL statements. Nothing more and nothing less. This did not need to be a lot of procedural code, but a lot of developers will come in and code this way. Here was another one, and this just shows that this is language independent. Okay, so this is from the daily WTF, worse than failure. And this will be a transact SQL example. So not necessarily PL SQL, but just in the same sort of sense. Using stored procedures. So they declare a lot of variables. Then they start with a select statement, and they say select into this variable the max of this column from this table where this column equals the input variable. So this must be something that came in. And I look at this code and I can sort of figure out what they're trying to do here. Somebody sent in a primary key, the variable that's highlighted. We're going against this table, and we're getting what appears to be a foreign key to another table because we're using it in queries against these other tables. Now I see they did a little trick here. This is probably a primary key. So why did they use max? Because max gets at least 1 record and at most 1 record if you don't have a group by. So they sort of avoided the no data found issue. This query always returns a row. And it will either return the maximum value for that column, or if there was no data matching the where clause, it will return null. So they go against one table, and then they go to this second table where they take the column that we fetched into, and they use that in the where clause, so that's that foreign key, and they're getting the first name and the last name out of that table. Now, most of you could probably see how those 2 SQL statements should be 1. Right? We could do that in a single SQL statement. Now, once we get that, they needed to make sure that the nulls problem wasn't a problem here. And so they would use the select statement to assign something as a default value for the first name and the last name if that came back null. So now hopefully most of you could see how these 3 SQL statements should have been a single SQL statement. But it gets better, because in addition to the first name and last name, they also needed the email address. And notice what table they're hitting. It's the same table as the first name, last name, and the where clause is identical. All they did was they went back and picked up the email address, and then they needed the title for the person. Same table, same where clause. If the title is null, I guess they didn't like this approach to assigning or setting up null values anymore, so they came up with another unique way to do it, right? And then they keep doing it, and they keep doing it, and they keep doing it. And they do it, and they do it, and they do it. And at the end, they do yet one more select to move all their output variables into the equivalent of a ref cursor in SQL Server to send it back to the application. And the developer says, it's actually better this way, the coworker said. You get a lot more control over things when you need to change it. Because you can see how this code sort of evolved. They said, ooh, we need this attribute, or we don't need this anymore. You just delete a SQL query. As a DBA, procedures like this should be the scariest thing ever. Because you look in your system, It's 100% utilized. But you look at all the SQL statements, they're all tiny. None of them do any work. They do 3 or 4 IOs through an index and 1 more IO against a table. But what you as a DBA don't realize is the underlying code is this ugly. It's doing that little query over and over and over again. You know, if there were 20 queries in here, we hit that index 20 times, that's at least 60 to 80 IOs, when it should have been 3 or 4 at most. DBA can't tune this. That should have been 1 SQL statement. There's no excuse for having any procedural code in here at all, yet it happens all the time. Always look at the procedural code and ask yourself, is there a set-based way to do that algorithm? So for example, I'm frequently called into customer sites, and I only get called into customer sites when they're mad at us, right? I never get to go to the happy customers. So I go into this customer site and they say, you know, we're going to give up Oracle. We're going to switch to DB2 because we had the best Oracle consultants we could hire come in and write a system for us, and it's really slow. Really, really slow. And IBM was in here and they say DB2 is faster than Oracle, so we're going to switch. I said, well, give me a chance. Just explain to me what's slow. Where's your pain points? They go, okay, we load a data warehouse, and that's really slow. And then we query the data warehouse, and that's really slow too. So it's basically everything is really slow. So I said, give me some of your code. And this was a typical piece of code that they used to load the data warehouse. They would join together a whole bunch of tables and insert all the rows into basically the big spreadsheet table, right? So it wasn't a star schema or anything like that. It was a big spreadsheet table. That's okay. That insert, we can play around with that and everything. But then they ran this thing afterwards, which they called a deduplicate loop. They would load all this data, and then what they would do is they'd come and they'd delete all of the rows in the table using this where clause. Well, I looked at this where clause, and it took me a while to figure out what they were doing. But basically, they were loading employee information with status dates, effective end dates on the record. So they might have loaded 5 records for me with status dates of January 1st, February 1st, and so on. You know, as I got promoted, as I got a raise, as I got transferred, as I moved, and so on. So they would load maybe 5 records for me. Then they would come and they'd run a select statement, select empno, minimum of status date, get the oldest date, just one old date, from this table for each employee number whenever the employee has more than 1 record. So they would find my oldest status record and delete it. So now I'm down to 4. And since they deleted at least 1 record, they would do it again. Then they delete my 2nd oldest record, and my 3rd, and my 4th. And then they find my 5th record and say, he only has 1 record, delete no more. Isn't that a really bad way to load a warehouse table? Put in 5 times as much data as you need, and then go and remove 4/5 of the information from a table that you're going to full scan frequently, and do it in the most inefficient way possible. So I looked at this code, and I basically wrote down what it did, and I put it up on the whiteboard for him as I was walking through my findings and my suggestions for the right way to do this. And I said, this is the logic that it would go through. You know, it would get rid of my oldest status records and leave the last one unless I had 2 status records on the same day. Like maybe I got transferred and I got a raise on the same day. I would have 2 status records. This code will get rid of both of them. And they said, no, it won't. I said, yes, it will. They said, no, it won't. Yes, it will. And what I had to do was actually load up a table with sample data and walk through it and say the first time through, we would get rid of the blue records. The second time, we'd get rid of those blue records. The third time, because that last 2 rows on there have the same status date, the count is greater than 1, we would get rid of both of those, and this table would end up with 1 record. And they still didn't believe me. So I had to put it in a database table and run the code. And they said, okay, apparently we have a bug in our application. And I said, this is how I would write this, as a single insert. Let me take your data, I'll take your join, and what I'll do is I'll get the maximum status date for each employee. the most current record. That's the one I'm interested in. And what I'll do is I'll count the employee records by empno and status state. I'll use those analytic functions. So as I'm running your join, I'll get 2 extra columns, and all I need to do is keep where the status state is equal to the maximum one and count equals 1. I'll use an insert append. That's a direct path load. I can load the data compressed. I can bypass undo and redo on this load, and I'm doing everything in one insert statement. So all of a sudden, my data load went from taking as long as this insert took and this loop as many times as it needed to execute down to just running the insert. And the insert ran faster because it's using a direct path load in this case. Okay? So all of a sudden, the load was really fast, and the warehouse queries were incredibly fast because they were querying against tables that were 1/5, 1/6, 1/10 the size that they used to be. Because I'm not loading 5 times as much data as I need to and deleting a lot. I'm just loading what I needed, loading it compressed. So everything was faster. And they looked at this and they said, yeah, but this insert statement, that's some nasty complex SQL. It's not as simple as this. This is really complex. I don't understand it. And I said, well, I really wouldn't go production with this insert statement. This is the insert statement I would go production with. Now it's a lot less complex because I actually tell you what I'm doing in front of it. And if you think that this code is more understandable because it's procedural, well then explain to me why it took me half a day to convince you that it has a bug. You don't even know what this code was actually doing. Right? This code works. It does exactly what the old code did. And in order to fix your code, all I needed to do was drop that where count equals 1 down here at the bottom. This would load all of my last status records. So if I got transferred and got a raise on the same day, I would end up with 2 records. And if that's not what you want, we would just change the logic a little bit. I would add row number. And what I do is break the data up by empno, order the date by status date, and assign the numbers 1, 2, 3, 4, 5. And I'd only keep the first record for each employee. And this becomes pretty straightforward. Once you learn the analytics, this isn't even scary anymore. And so they still use Oracle because it runs faster than fast enough now, but it's because we removed procedural code. So it's sort of funny, I'm giving you a talk on effective PL SQL, and I'm telling you to write no PL SQL. That's the most effective PL SQL on the planet. Less code, less bugs, typically faster. So here's another piece of advice on writing as little as possible. When you're writing code, make sure your routines, your methods, functions, whatever you want to call them, fit on a screen. Run out and buy the biggest monitor you want, but make sure the logic can fit on a screen. Otherwise, you can't understand it. If you have to page up and down, it's too complex, too much code in a single routine. Break it up. You know, in the old days, that used to mean I had 24 lines for a subroutine because monitors used to be 24 rows by 80 columns or even smaller. Now they're much larger, but just make sure you can see the entire thing. Use packages. The first reason why is they break the dependency chain. And this was most relevant in 10G Release 2 and before. It's not as relevant today, but you should still use packages. But back in 10G Release 2 and before, if you created a procedure P1 and another procedure P2 that called P1, both would be valid. If you replaced P1, so you modified the stored procedure P1 that P2 calls, P2 would go invalid immediately. And you'd have to recompile that code as well. If you used packages, that would not happen. If P1 was in one package and P2 was in another package, and you recompiled the package with P1, you would not have to recompile the package containing P2. It would not go invalid. It breaks the dependency chain. In 11G Release 1 and above, this would actually change. If I create or replace procedure P1, P2 would stay valid in 11G Release 1 and before. It was a new feature of 11G Release 1. If I didn't change the inputs or outputs of a stored procedure, we knew that none of the other code could be affected by the create or replace, so it would not cascade the invalidation anymore. They increase your namespace. You can only have one procedure P in a schema. What about that addition-based redefinition thing I just finished with in the first presentation? That actually allows me to have two versions of procedure P in there, but there's really only one procedure P in that schema. But if I use packages, I can have a procedure P in every single package. I put lots of functions into a package. This increases my namespace because the package name needs to be unique, not the procedure and function names. They support overloading. Overloading means I can have in a package, in one package, 5 copies of procedure P, and they only differ based on the inputs that they take. This is a feature that could be viewed as positive by some, negative by other people. To me, I view it positively. Overloading can be very useful in API, application program interface packages. If you look in the data dictionary, 259 out of 728 sys-owned packages, the APIs to the database, employ this technique. You know, DBMS SQL, if you've ever used that, has a routine bind variable. We're back to bind variables again. Bind variable is overloaded to take numbers, dates, strings, clubs, raws, and so on. So you don't have to call bind variable number, bind variable date. You just call bind variable and pass it the inputs, and it picks the right routine based on the inputs. It helps you live up to that fits on a screen rule. You can break stored procedures up into tiny little pieces if you're using a package, because all of a sudden you're not afraid of having 50 subroutines, because you're really only exposing one package name. But if you were just using stored procedures, you would be tempted to build humongous stored procedures so that you didn't put into the data dictionary 50 or 60 different unique names. Use static SQL. There's 2 types of SQL inside of PL SQL. The stuff you just type in, /x and select star, that's static SQL. It's known at compile time and does not change at runtime. The only thing that changes about it would be the inputs, the bind variables to it. There's also dynamic SQL, where you can build the query in a string and dynamically open it at runtime, fetch from it, and so on. Using static SQL, the advantages are, you know the SQL will probably execute. It is syntactically correct. We know that at compile time. You have access to all the underlying objects. We know that the tables you're querying, you've been granted access to get at them. So you know the SQL will probably execute. It could still raise a runtime error, divide by zeros and things like that. But the SQL itself is syntactically correct, and the objects it's accessing are known to be accessible by your stored procedure. It will create the record types for you. If we know the SQL at compile time, we can automatically create variables of the right data types, records of the right data types, and so on. The compiler does more work, so you don't have to. All the referenced objects, the dependency mechanism kicks in. I create a stored procedure using static SQL. I can tell you what tables it accesses, what views it accesses, what synonyms it uses. I can tell you everything needed for that stored procedure. So you can look in the data dictionary and answer the question, is anybody using this? Well, if you're using stored procedures with static SQL, you can answer that question very easily. And if something changes, you know right away if something's broken. If you alter a table that a stored procedure uses, that stored procedure will go invalid. So you know immediately all the affected objects, they're invalid. You can then go try to recompile them, and if they don't recompile, you know it's broken. If you got all your SQL outside the database in Java or C# or Visual Basic, you'll find out you broke something slowly over time as those applications start throwing error messages, because you don't have that tie between who's using what tables. Dynamic SQL makes it easy to lose out on the benefit of parse once, execute many. In PL SQL, your static SQL will in general be parsed once and then executed over and over and over again. PL SQL caches it. It can't always do that with dynamic SQL. With DBMS SQL, you definitely have to do it yourself. You have to make sure that you don't call parse on the same SQL statement over and over and over again. So you have to write the procedural code. With native dynamic SQL, as long as you're using the same SQL text over and over again, we'll cache it for you. But if you're executing the same exact SQL statement over and over again, why did you use dynamic SQL? Dynamic SQL means you're changing it. So this probably doesn't happen very often. And the last reason is it is impossible to be SQL injected if you're using static SQL. SQL injection is this really bad security bug. If you're building SQL bit by bit in your application and then parsing it, you are subject to this thing called SQL injection, especially if you take end user input parameters to your routine and you concatenate that input into your SQL statement. The end user or the other developer who invokes your code might be able to change the meaning of your SQL statement, and that's a bad thing. With static SQL, it is impossible to be SQL injected. It cannot happen because the SQL is known at compile time. The SQL cannot be modified, cannot be changed at runtime. So it's impossible to hit this security bug. So when should you use it? Dynamic SQL is something you want to use when static SQL is not practical. When you could take hundreds or thousands of lines of repetitive code, if then else's to open up different queries and whatnot, and turn that into significantly smaller code using dynamic SQL, then it would be appropriate. Less code, less bugs. So I wanted to make a smaller routine, significantly smaller, hundreds or thousands of lines. When you've shown that using static SQL would not be practical, that is, using dynamic SQL should never be your first choice. It is only done after you've ruled out the practicability of static SQL. So, bulking up. This is using array processing or bulk processing. It's a method to bug the database less frequently. Instead of going to the database for every row you want to get out of a table, you go to the database and say, give me the first 100 rows, and you get them, and you process them. And then you say, give me the next 100 rows. So it's a way of cutting down the round trips between you and the database by an order of magnitude or many orders of magnitude. And even though we're in PL SQL, and PL SQL is already running in the database, this has a significant impact on our runtime performance. It's really important if I'm an application outside the database to use bulk processing. It's still vitally important inside of a PL SQL routine. So when do you need to do it? When do you need to explicitly code bulk processing in your application in PL SQL? You need to do it when you retrieve data from the database and you send it back. For X and select star from a table, get a record, process record, update the record back in the database. So if you're reading a row, updating a row, read, update, then you want to employ bulk processing. You do not need to do it when you simply retrieve data from the database. You're populating a screen in an application. You're running Ask Tom, for example, that application, and you do a search. I don't need to employ bulk processing because I'm just retrieving data from the database and putting it on the screen. The database already bulk processes for me in that case. Here's the examples. You need to bulk process when you have code that looks like this. For X and select, loop, some process against that row, and an update of that row back into the table. Here, we're doing things row by row. We need to take that update statement and batch it up. We don't want to update a row at a time. We want to update 100 rows or 500 rows at a time. You don't need to do it when you have code that looks like this. For X and select star from the table, loop, display the information. Write it to a file. Put it on screen. Note the data is coming out of the database and is not going back into the database. So there's no update, insert, or delete inside the loop. If you have a case like this, you don't need to bulk up because Oracle has already bulked up this select statement for us. This select statement, whenever I use an implicit cursor for X and select star, for X and cursor name, Oracle implicitly array fetches 100 records at a time for me. This is already doing bulk processing. This select statement up here is doing bulk processing as well. The update is not. We would need to make the update be bulk processed. And the way we do this is by writing a lot more code. This is just an example of what the bulk process code would look like. You have to declare some variables and data types, array types. You have to use an explicit cursor up here to find the cursor, open it, fetch bulk collect, some number of rows. I limit it to n rows at a time. I set n to 100. Once I get those, I have to run another loop that does my procedural process against that data. And once I've processed those 100 records, I can then do the bulk update back to the table. But once again, this would be compared to the simple non-bulk code for X in the same select statement, do the procedural process against that row, and then do a single row update. So this is the good code. The big code is good. The other small code is bad. That seems to conflict with my write as little as possible. But what I said was write as much as you have to and as little as you can. In this case, the least amount of code you have to write is the big stuff over here. Because if you were to run these two pieces of code and compare their performance, you would see something like this. Here's the TK prof from the bulk process. Okay, so if I look at this update statement, I can see I executed the update statement 719 times to update 71,825 records, and it took about 12.83 CPU seconds. The other one that did the update one row at a time, it called it 71,824 times, used almost twice as much CPU, 21.25. And that's because we were going back and forth and back and forth and back and forth. So this is why you want to write the bulk code. That's why the big code is better than the small code. However, if you ask me, the only correct code would be an update statement. So let's take that bulk where we did the 719 at 12.83, and I just rewrote that. Instead of read a record, process a record, write a record, I just did all the work in the update statement. I found a set-based way to do it. I executed it once, and it goes from 12.83 down to 1.3 to update exactly the same number of records. The more bulky you can make your process, the better. And you can't get any more bulky than a single update statement. That would be the right approach here. Returning data. I want to return data to a client application outside the database. Either use simple formal out parameters, meaning have a stored procedure with in-out parameters, and just call it like any other procedure or function in any other language. Or, if you need to return a set of data, use a ref cursor. Far too often I see people run the query in the stored procedure to populate a collection, PL SQL index by table, a nested table, or a V-array, and then return the collection to the client. That's the wrong way to do it. Do not do that. Use a ref cursor to return sets of data. That makes it easier to program. Every client can handle a cursor and can fetch from it. Returning a collection to a client can involve writing a lot of code to interact with that collection. It also gives you flexibility. The client decides how many rows to deal with at a time. Less memory intensive. If your result set has 1,000 records and you use a ref cursor, when you return the ref cursor, you return about 80 to 100 bytes of information, nothing else. When the client goes to fetch from it, then you'll get, say, the first 100 records, and you return however big that is, but you don't have to return all 1,000 records in one big call. If you use the collection, your stored procedure would have to read all 1,000 records, put them into a variable, a collection, and then send that variable along over the network to be unpacked on the client and then utilized. And that would be the slowest, least efficient way to do that. Just run the query itself. And also consider that the client might be wanting that data to put it on the screen in your application. They want to get the cursor so they can display the first 25 records as fast as possible. If you use the collection approach, not a ref cursor, they will have to wait until you get the last record out of the database table. If you just return them the ref cursor, now they only have to wait for the first 25 records to come out of the table. It's much more efficient. The response time will be faster for the end user. If there were 1,000 records in table T, this piece of code on the top would call fetch 10 times, getting 100 records each time. Same 1,000 records using this piece of code here, this would actually call fetch 1,000 times. I'd have to write a lot more code to make this bit on the bottom as efficient as the bit on the top. So the implicit cursor, when possible, should be used. And implicit cursors are safer than explicit cursors code-wise. Less code. These two things do exactly the same thing. One of them has less code, therefore less bugs. Single row processing. Definitely select into. There's no other way to do it. Don't be afraid of select into. Don't try to find a way out of using select into. It is the right answer. Here's the implicit way. Select into some PL SQL variables from table where clause. Explicitly, what you would have to do to emulate this one SQL statement in PL SQL would be declare the cursor, open the cursor, do a fetch, have a check. If it's not found, then raise no data found. Then, and this is the part a lot of people don't do a second fetch. Because with the select into, you get at least one record and at most one record. You now need to do a second fetch and make sure you don't find anything the second time around. Because if you did, that's a bug. You were expecting one row and you got two. So there's some logical data inconsistency here. If you find something, raise too many rows and then close the cursor. These two pieces of code are identical. The one on the top is not only faster, it's safer. It does all that logic for us. Here's a bug. I see this a lot. You have a function to get something from a table. And here's the code that I'll see in the stored procedure. Open the cursor, fetch in the PL SQL variables, close the cursor, and return them. What's missing? All of this logic right here. They didn't check to see if they got anything. Right? What if there is no data? Nobody would know. The fetch doesn't raise an error. The fetch sets an attribute, cursor % not found. So there's no error that would be raised if there was no data. That first routine would return probably null back to the invoker. Probably. Depending on how PL SQL variables were defined, whether they were in-out parameters or whether they were local variables. But probably we get null back. Here's another one that I see frequently, and this happens because the developer is doing the loop inside of a loop. They don't want to join in the code. They want to take it easy on the database, and they're not doing the select into processing. So they open up their first cursor, they fetch into some record, they exit when it's not found. That's good, so they're only processing the records they should fetch, so there's nothing wrong with the processing against C1. But now they open up a cursor C2 based on the data they just fetched, and they fetch C2 into something else. And then they close C2, so this is their select into processing right here, and then they call a subroutine process, and they pass it the data from the first cursor and the second cursor. What if, on the second time through the loop, the data we fetch from C1 causes us to find nothing in C2? What would be in that second set of something else variables? It would be whatever was left over from the first time through the loop. So there would actually appear to be data in there, but there wouldn't. So this is an even worse bug. If you replace the open fetch closes with select intos, you would find those bugs immediately. They would be very apparent. Which is easier? This piece of code that does the 4x and select star from a table and a loop, or this one where I have to do this, where I have to open the cursor, fetch a row, exit when not found, process it, close the cursor. The first one's infinitely easier. It's a lot easier to type in, it's a lot easier to test, it's a lot easier to verify that it's correct because it's less code. The first one is also more performant because it does the array fetching. The explicit code would have to be a lot larger to be as efficient as the implicit code here. So the implicit cursor, when it's possible to use it, would make sense. Multi-row processing. This is nice too. It has all the benefits. It looks like I'm using an explicit cursor up here, It has all the benefits of an implicit cursor because notice I'm not doing open or close. So this, even though it looks like an explicit cursor, is an implicit cursor. This has all the benefits of this piece of code down here. These two pieces of code are identical. One thing I'd like to point out, you will have access to all of these slides. So these code snippets, you'll be able to download these from Ask Tom and compare them yourselves. And I would encourage you, if you want to reuse these presentations. So feel free to take this and at work, deliver it to your coworkers. Beat them over the head with it and say this is the right way to approach these things. So, is there ever a time to use explicit cursors? Here's something I like to say. Never say never. Never say always. I always say. Parse that statement, right? It's sort of an infinite loop. There is a time when you want to use bulk processing, right? I already talked about that. And in order to use bulk processing for the update, you need to be using explicit cursors because you need to fetch 100 records into an array, process the array, and then send the array back to the database. That's when you can justify the explicit cursors. Beware of. So here's some things to beware of. When 11G was first coming out, the guy who owns PL SQL, his name is Bryn Llewellyn. He's the product manager for it. He came to me and said, you promote PL SQL a lot. You talk about it a lot. You know it really well. I'll give you 3 wishes. You can add 3 things to the database. And I thought about it for a minute, and I said, I don't want to add anything. I want to take away 3 things. I'd like 3 things to be removed. Okay? And the first one was when others. And the reason for this is not because when others is 100% evil. None of these are 100% evil. They all have valid cases where they should be used. The problem is they're almost always used incorrectly. The #1 cause of bugs in PL SQL code that I see is a when others. Because it would be when others, then null. When anything bad happens, ignore it. Don't tell anybody, right? It would be embarrassing if my code raised an error. That's really bad. Or equally as worse is when others, then log the error in a table, return. The caller still doesn't know anything went wrong. Re-raise the exception. The only valid use of when others in my life is when others, then log the error, raise. Use an autonomous transaction, my second evil PL SQL feature, in an error logging routine so that the error logging routine can do an insert into a table, log it, and commit, but not commit any of the outer transaction itself. So beware of the when others. Make sure it's always followed by a raise or raise application error. In 11G release 1 and above, when I gave this to Bryn, he said, we can't take when others away, but what we can do is turn it into a compiler warning message. In 11G, when you compile code that has when others, not followed by raise or raise application error, we will raise a warning for you. I felt that the warning should have said, you have a bug in your code, fix it. Bryn said, we'll just warn them that they have a when others, not followed by a raise or raise application error, and that's an area of concern, right? So they didn't take it away, but they sort of made it so we can see it. Autonomous transactions. This is the ability to do things like commit in a trigger. Sounds like a good idea, commit in a trigger. That's the worst idea on the planet. Never use it to commit in a trigger, because what happens if you roll back? Right? All of a sudden, the committed stuff is still happening. There's one use for autonomous transactions, exactly one, and that's to create an error logging routine that you use in a when others clause that's followed by a raise. So those first two go together, right? We should have, instead of giving you autonomous transactions in 8i, we should have given you an extensible error logging package. We could have saved a lot of people trouble, because people will use the autonomous transactions to do things like avoid a mutating table constraint in a trigger. A trigger can't read the table it's firing on unless you use an autonomous transaction. But then the trigger's reading the view of the table as the table existed before the transaction did. They won't see any of the changes that you've been making, which makes it almost useless, which makes it a bug. Which leads me into the third one, which is triggers, especially triggers that use autonomous transactions that have a when others then null in them. Right? Those are the worst ones of all. Triggers have their use. They definitely have their use. But I see them abused more often than used correctly. Developers will try to use them to put some magic into the system. Let me fix the code without fixing the code. And what invariably happens is 3 years from now, somebody forgets that the trigger's there and they do something disastrously wrong because of its existence. Or the developer will use the trigger to try and enforce integrity in the database in some way, shape, or form. Let me make sure that I have a parent-child relationship here in place. I didn't want to use foreign keys and primary keys. I'll do it myself. Well, in Oracle, reads don't block writes, writes don't block reads. In a multi-user environment, I can't see your changes, you can't see mine. My changes don't block you, your changes don't block me. It doesn't work. I need to use the lock table command. Anybody who's doing reference integrity or any sort of complex integrity constraint in a trigger, probably 99% of that code does not work in real life. Just give me the trigger code and I'll look at it and say, what if user 1 does this and user 2 does this, and then they both commit? You'll have bad data in your database because you didn't use a lock table command. So using triggers when you should have used another database feature, like referential integrity, is a bad idea. And lastly, some things to do. Instrument your code. What I mean by that is put a lot of stuff in the code that makes it so that when it's running in production and it's not running correctly, you can update a row in a table and get a big trace file from your application. Just like we can always turn on SQL trace to tell you all the SQL and how it's performing in your application, do the same thing in your application. Make sure you can turn on a trace and go production with it. Take that debug code into production. Because in production, they won't let you drop in a new version of your code to find a bug, but they will, for whatever reason, allow you to update a row in a table. So if you make your debug stuff, table-driven, you'll be able to get this trace information from your production system. Use the tools. SQL Developer. It is for free. It's got built-in source code debugging. You're sitting there, you're running PL SQL in the database. Maybe you need to single step through it. Okay? Maybe you need to watch variables, set breakpoints. Set a breakpoint in that trigger and see what happens when the trigger's fired. Performance, hierarchical profiling. Figure out what the procedures are calling each other and how long each one's taking. Tracing tools, Ash and AWR are built into SQL Developer as well, so that you can get access from a developer perspective to a lot of this tracing information. PL scope, this is cross-referencing. In SQL Developer, you can hover the mouse over a variable, and SQL Developer will tell you where that variable was defined, where it's referenced, and where it's assigned to. So you have every advantage that you have with Java, C#, and so on, you have it inside of this tool. And always test things out, especially advice. I used to advise to use bulk collect for everything. If I had been giving this presentation in Oracle 9i, my advice would be different. In Oracle 9i, implicit cursors did not array fetch. They fetched a single record at a time. Starting in 10G, that implicit array fetching that I was talking about started. And so the advice changed. So you have to watch out for that. Things change over time. Question authority, ask questions, in a friendly way, of course, but feel free to ask questions. Okay? Thank you very much for your time and attention. Hope you enjoy the rest of the day.
Vou aproveitar mais alguns minutinhos, acho que todo mundo conhece o asktom.oracle.com e vamos então aproveitar o momento para fazer ao vivo alguma pergunta que vocês queiram aproveitar esse momento para a primeira vez no Brasil, né, o Tom Kyte. Alguém gostaria de fazer uma pergunta? Pode ser em português mesmo, ele vai estar com um aparelho de tradução. Aproveitem.
Eu gostaria de perguntar os impactos de mexer no otimizador. Assim, de modo genérico, porque muita gente não compreende o otimizador, infelizmente.
Yeah. So I think the question's about hinting more than anything, touching the optimizer with hints. And that's the way you can interact with the optimizer. And in my opinion, there's two types of hints, good ones and bad ones. The good hints are ones that give the optimizer more information. Select all rows. Optimize this query to get the last row as fast as possible. Select first rows. Optimize this query to get the first record as fast as possible. If I'm in an interactive application putting data up on a screen, I probably want first rows optimization. Feel free to tell the optimizer that fact. That's important. Otherwise, it will come up with the wrong plan. Another one, in a reporting system, I might have a where clause against a table of people, such as give me all the rows where the month the person was born is December and their zodiac sign is Pisces. Now, if you ask the optimizer to figure out how many rows that's going to figure out, what it would normally do is ask the question, how many people are born in December? Statistics tell me about 1 out of every 12. How many people are the zodiac sign Pisces? Statistics tell me 1 out of 12. But if I ask the question, how many are born in December and Pisces, we all know the answer should be 0, because all of us Pisces are born in February or March. None of us are born in December. There's a relationship there. But the cost-based optimizer is going to figure that's 1/12, multiply them together, 1 out of 144 records is going to come out of that table because of that. What I want to do is give the cost-based optimizer the ability to figure out what the real answer is. It had a guess. So I have another hint, dynamic sampling. This is a good hint. I can tell the optimizer when you hard parse and you guess, use a dynamic sample. Go out and query the table real fast and validate that guess. And instead of guessing 1 out of 144, it's going to guess much closer to 0. And it's going to get the right query plan. So look at hints that give the optimizer more information. Avoid hints like index, use NL, hash, and so on. Those tell the optimizer how to do something. If we use the hints that give the optimizer more information, the optimizer can figure out the best way to do it. So many times I see people using the index and use NL hint when they really meant to say first rows. By default, the optimizer does all rows optimization. Many applications need first rows. So don't be afraid to use those good hints, but avoid the bad ones.
Thank you. Mais alguma pergunta? Alguém quer arriscar? Bom, eu tenho uma pergunta. Durante anos, a Oracle vem implementando novas features. Existe alguma feature que não foi implementada ainda? Que você gostaria de ter?
That's always a hard one, because I remember when version 7.3 came out in 1995, I thought we were done, because I looked at the feature list back then, and then version 8 came out with a whole bunch of stuff. So what would I like? I do know one feature I would like that I know they're working on. I do a lot of programming with Apex. That's how Ask Tom works. And one common thing that many applications in the middle tier need to do is page up and down through a result set. Right now, if I want to go from page 1 to page 2, in Apex, I have to open up the cursor basically, throw away page 1, and show you page 2. I'd like to be able to open a cursor and then tell Oracle, don't close this, I'm coming back for it. Give me something I can remember so that I could tell you later that I'd like this cursor back, so that I could fetch page 1 and display it, and then 5 minutes later, in another session, come back and say, I'd like that cursor again so that I can get page 2. And even make it a scroll cursor so that I could go backwards and forwards through it. So we need, that's one capability I've been looking for since about 1995, right? Since we started developing things on the web and we didn't have a client-server connection, where it was really easy to open a cursor, get a page, and then come back and get page 2 later.
Thank you.
Okay.
Alguma pergunta? começando a ficar animado já.
Hey Tom, you talked about many features. You talked about many features of 11G version, but I want to know about result cache function.
Okay.
Can you tell us about that?
Okay, sure. In 11G, there's three new types of caches. There's a client-side cache, a server-side query cache, and a server-side PL SQL function result cache. The client-side cache and the server-side query cache are very similar. You can almost think of them like a just-in-time materialized view. A materialized view, a DBA would normally create way ahead of time and actually store the results of some query in a table, so that when you or I would write a query against detailed information, the optimizer would say, I already have it over here, answered, and it would just redirect it to the answer for us. With the server result cache, it's very much like that. We would run a query that goes against a big set of data and turns it into a small set of data. Either it finds a few rows, or it takes lots of rows and aggregates them to a few rows. It then has the ability to save that in the shared pool, so the next time you run the query, or they run the query, anybody runs the query, will immediately go to the answer, not to the raw table, as long as the table has not been modified. So if you have a query that goes against a lot of data, turns it into a small set of data, and the data it's querying is not changed frequently, then you can use this server result cache. The client result cache takes that a step further and says, I'm going to remember the answer on the client side, so that if I run that same query from my client application, I don't even have to go back to the database for it. I've already got it in the client side, and it's transparent to the application. You don't have to recode your application to take advantage of this. And the trick here is, if the database updates a table that makes your cached result invalid, the database is responsible for notifying your application. So you don't have to do anything to make sure that the cache in the client stays consistent with the server. And the third one is the PL SQL function result cache, where the first time you run a result cached PL SQL function, and this is a compiler directive you would put on the PL SQL create statement, the first time you run it, the database will go to the shared pool and say, I don't see it there yet, so it would run your code, and then it would put into the shared pool the name of your function, the values of all your inputs to that function, and the answer. So the second time you run it, we don't actually run your code. We just get the answer out. Unless any of the tables your function relies on, your function queries, have been modified. If any table has been modified, we automatically invalidate that result. And so those are three transparent caches that you're able to use in your application without having to rewrite a ton of code. And those come with 11GR1 and 11GR2. So they're not options or anything. You have access to them pretty much universally.
Ok. Bom, nosso tempo está estourado aqui. A gente vai ter que dar início à próxima apresentação. Então, eu queria agradecer novamente ao Tom pela presença. Thank you very much for coming. E uma salva de palmas, então, para Tom.